This is Pre-Calc section 11.5, part 3 on partial fraction decomposition. This type is going to be distinct linear and non-repeated irreducible quadratic factors. Sounds complicated, but it really isn't that bad. This video will cover number 5 and number 6 in your packet. Let's look at what these two definitions refer to. Distinct linear is something like x plus 1. It is a linear factor because the degree of that polynomial is 1. That makes it a linear factor. This is a non-repeated, irreducible quadratic factor. What do we mean by irreducible? We mean we can't factor this. X squared plus 2x plus 4 cannot factor. Now, if this had been x squared plus 5x plus 4, then that would be factorable, and that would factor into two more distinct linear factors. But that's not the case. It is something that will not reduce, it will not factor. So we have our two parts. We have x plus 1 becomes one of the denominators, and we have x squared plus 2x plus 4 becomes the other denominator. Notice I've already filled in the a right here for this numerator of this linear factor. Anytime you have a linear factor, you have one constant letter up there. But it changes now when we talk about a quadratic factor that cannot be factored. What this has to have as its numerator is bx plus c. Think of it this way. The degree in the denominator is 2. The degree in the numerator will be 1 less than that degree. And it also has to be in this form, which is definitely linear. So what we're going to do now is what we've done before, and that is multiply by the common denominator. My common denominator is this big denominator right here, which I've written on both sides. When I multiply this side by this denominator, all of this goes away, and I just get x squared plus 2x plus 3. And over here, I will move this over the x plus 1 because I cancel the x plus 1 out with that I've covered up. And this is a times x squared plus 2x plus 4 plus. The next thing is to multiply this by this denominator, which makes this go away, and it goes away with this. So that leaves me bx plus c, and you need to remember to put that in parentheses because that is a binomial numerator. It needs to be in parentheses times x plus 1. So similar to the ones we've already done, it's just this bx plus c numerator which changes things or seems to make it a little more complicated. It just makes the arithmetic a teeny bit more complicated. So we still have to choose values for x. Because of this linear factor, which was x plus 1, we're going to let x equal negative 1. But we don't have any other what I call nice numbers to stuff in for x because of this x squared plus 2x plus 4 being an irreducible quadratic factor. So this is where you get to choose what we ought to plug in for x. Be smart. Let x equal 0 would be a really good number. And since we've used negative 1, it'd be a good idea to use positive 1. Remember, you can plug in whatever number you want, but keep the number small. And if you can use 0, use 0. So now I just need to go through all this arithmetic. I'm putting negative 1 in for all of these x's. And then you just got to be careful with your arithmetic. So negative 1 squared, that's a positive 1. 2 times negative 1 is negative 2, plus 3 is going to give me 2 equals. Come over here, negative 1 squared is 1. 2 times negative 1 is negative 2, plus 4. This is in parentheses. 1 minus 2 plus 4 is 3, times a gives me 3a. And when I get over here, I'm going to jump all the way to the back side here because negative 1 plus 1 is 0, and 0 times this part, whatever it is 0. So that part is going to go away, just giving me this simple equation to solve, and this is going to give me a equals 2/3. Now, I'm going to erase what I plugged in here and plug in 0 in a second. Plugging in 0 for all of these x's. And of course, because we're talking 0, this arithmetic really ought to be easy for us. 0 squared plus 0 plus 3 is 3 equals 0 plus 0 plus 4. So 4 times A is 4A. And over here, 0 times B is 0, but this C is still there. And 0 plus 1 is 1, so that gives me plus C. Now, you might think you can't do anything with this because you have two variables, but remember, you have a value for A. Plug 2/3 in for A and solve that equation. So this is 4 times 2/3 plus C. This is 8/3 plus C. And to solve this, we will subtract 8/3 from both sides. You can get a common denominator, or you can use your calculator to do that arithmetic, and C works out to be 1/3. Same thing over here. I've got to erase this right here, and this time I'm going to come back and plug +1 in and do all of that arithmetic. So 1 here, 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 and here, and do that arithmetic. This is 1. 2 times 1 is 2. Plus 3 gives me 6 equals 1. 2 times 1 is 2. Plus 4 gives me 7 times A. So equals 7A. Plus B times 1 is B. Plus C. 1 plus 1 is 2. So this needs to distribute the 2 through there. Gives me 2B plus 2C. Yes, we have 3 variables, but we do know 2 of them already. So I can plug in and do the arithmetic. This is 7 times 2/3, because that's what A is, plus 2B, which I don't know what that is yet, plus 2C, C is 1/3. And just clean that up and do the arithmetic. 7 times 2/3 is 14/3, plus 2B. 2 times 1/3 is 2/3. 14/3 plus 2/3 is 16/3 plus 2B. Subtract 16/3 from both sides. I don't have any room right there, so we'll come down. Subtract 16/3 from both sides is going to give me 2/3 equals 2B. And where'd the 2/3 come from? You can type this in your calculator. 6 minus 16/3 will give you 2/3. To solve this, divide both sides by 2. 2/3 divided by 2 is 1/3. Again, if you're not very good with fractions by hand, plug this stuff in the calculator. You can do 2 divided by 3, and then divide by 2 again will give you 1/3 when you change it back to a fraction. Those are my values for A, B, and C. A is 2/3. Remember, A was the numerator of this denominator, so this is 2/3, plus B, which is 1/3, X, plus the C value, which was also 1/3. So this is my partial fraction decomposition. 2/3 over x plus 1 plus 1/3 x plus 1/3 over that quadratic denominator. This one is very similar, but we have one extra step in that we've got to factor this, and you should know how to factor this. This is the difference of 2 cubes, which will factor into x minus 2 times x squared plus 2x plus 4. And if you don't remember how to factor the difference of 2 cubes, you can Google that or go onto my YouTube site and find videos on that. So those are my two denominators. X minus 2 is my linear denominator. And this is an irreducible quadratic, so it is my other denominator, x squared plus 2x plus 4. And from there, we have the same setup as we had a minute ago. The numerator of this, because it's a linear denominator, is A. Because this is an irreducible quadratic denominator, then we will have B, X plus C. And one comment here, since we've already used A, that's why this has got to be BX plus C. And it could be DX plus E. You pick whatever letters you want. It just makes sense to follow along in alphabetical order. So we are going to multiply both sides. That's the same thing we had on the other page. Multiply both sides by that common denominator. So when I multiply this side by that, all of this goes away and I just get 1. That's nice and simple. Then I have to multiply by this denominator. My x minus 2 is going to cancel out with this x minus 2. So I will move my little block over here to show you that that is gone. And I will have left a times x squared plus 2x plus 4 plus, this time I'm going to cancel out the x squared plus 2x plus 4. So move my block over, and what's left is bx plus c, the block out of the way, times, see that's gone away, times x minus 2. And now we're ready to let x equal the values that will be helpful. Obviously, because this linear factor is x minus 2, then letting x equal 2 is a good idea. We have choices here. Remember, I love to use 0 because the arithmetic is pretty easy that way. And if we've got 2 and we've got 0, it'd be pretty easy to let x equal 1 also. We're going to plug 2 in for all of the x's. You could always stop the video and do the arithmetic on your own and see if you can get the right answers. 1 just stays 1 because there's no variable there. So I'm going to put in 2 for each of these x's and do that arithmetic. 2 squared is 4. 2 times 2 is also 4. Plus that 4 gives me 12 times a, which is 12a. So that gives me 1 equals 12a plus whatever happens over here. But this is nice. 2 minus 2 is 0. 0 times that part gives me 0, so all of that goes away. So all I have is 1 equals 12a. Divide both sides by 12. So we have an a value of 1/12. So erase this stuff and write down that we're going to plug in 0 now and see what happens to our arithmetic. So if I put 0 here, 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 and here, remember this side just stays 1. I can just fill that in right there and do this arithmetic. 0 squared is 0, 2 times 0 is 0. So all that's left inside this parenthesis is 4. So this is 4a. b times 0 is 0, but the c is still there. So this is c times 0 minus 2 is negative 2. So c times negative 2 is negative 2c. So this is 1 equals 4a minus 2c. I know what a is. A is 1/12. So this is 4 times 1/12 minus 2c. 4 times 1/12 is 1/3 minus 2c. Subtract 1/3 from both sides gives me 2/3. Use your calculator if you have to. To get c alone, I need to divide both sides by negative 2, which is going to give me c equals negative 1/3. Erase this stuff. And now we are going to plug in and let x equal 1. Remember, that stays 1 because there's no variable. So this is 1 equals something. A, we're going to put 1, 1, 1, 1 and see what happens. 1 squared is 1. 2 times 1 is 2. So 1 plus 2 is 3. Plus 4 is 7. So this is a times 7, better known as 7a. And over here, b times 1 is b, plus c. 1 minus 2 is a negative 1. So I need to distribute negative 1 through there, which gives me negative b minus c. We have values for a and c, so I will plug those in. This is 1 equals 7 times 1/12 minus b, which I don't know, minus c, which is minus a negative 1/3, which turns that into positive. So this is 7/12 minus b plus 1/3 equals 1. 7/12 plus 1/3 is 11/12. Subtract 11/12 from both sides gives me 1/12 equals negative b, which means positive b is negative 1/12. And those are our values for a, b, and c. A was on top of our linear factor, so that's 1/12. And this is bx plus c. b is negative 1/12 x plus c. I could say plus negative 1/3, but MathLab would prefer it to be minus 1/3 over that quadratic denominator.